everyone. Today is day 7. We are going to discuss about live demo on the climate data analysis tool or community data analysis tools. As we have seen about what is the use of overall view of CDAT. Also, we have seen the live demo for the NumPy. Today, I am going to start with the installation of CDAT. Parallelly, I will go with the today's class. So first of all, we can install Miniconda. I already mentioned that we no need to install Anaconda. We can just go with the Miniconda. If you just search the Miniconda, then we will end up with this website. There are Windows is also there, Mac is there, Linux is there. So I'm choosing Linux. I'm going with the Python 2.7 since I'm using it past 10 years. I couldn't immediately move to Python 3, but one day eventually I need to move it. So I'm just downloading this Miniconda. Just downloaded. Then what we have to do, we have to just search Miniconda. It's asking to press enter to continue. Review the license agreement, that is open source license. You can see that the entire license. You can scroll down. That's a shell which then I'm just skipping this license, just queue, then I'm accepting this. That's open source license. When it is asking, now it is saying that Miniconda will now be installed into the location, by default home location. Inside the home, this folder will be created. I'm just press confirm, enter. Now it will come up with by default the Python 2.7, and along with that many packages. So it is asking like, do you want to initialize Miniconda by running conda init? Yes. So now conda has been installed. I'm just doing this conda config. It will be by default. Yeah, now the conda has been enabled. We can see that conda env list. Right now it's empty list, just it is having only base. Within this we are going to download CDAT. This is CDAT website. If you go there, you can go to the installing. That will redirect to GitHub. So here what I'm going to do, from Linux, I'm going to choose this latest version 8.1 Linux Python 2, and one more version called Python Mahalakshmi, where suppose if you are installing this conda or CDAT inside your HPC where there is no X. X means GUI, so you can't access the X. Then using your RAM memory itself, it will plotting. It will be useful for the plotting. Without the X, it will plot it. So I'm just going with this. Copy link. I'm downloading it using wget, and this also downloaded. Now I'm going to create conda env create -n environment name. This is the name which I am giving, and this is the file option which I downloaded YAML file. Now it will take some time, and it will ask question either shall I install or not. Then once we press yes, it will download some nearly 2 GB amount of data, and then it will download, and then it will install. Oh, conda memory and the conda processor ran out of memory. This is my brother's remote system. It has only 1 GB. At least it requires at least 2 GB. So tomorrow I'll try again installation in Mihir or in some other server. So today I'm unable to show the demo, the live installation. Sorry for that. So tomorrow I'll try to log into Mihir, and then I also can try, but the thing is there is no internet in Mihir. If you want to delete it, you can just see that mini conda has been created. So it's just 300 MB. The mini conda is 300 MB, but if you install Anaconda, it will download GBs of package. It will download and install. Instead of that, we are installing mini conda, and then within that we are installing only CDAT. It will occupy 2 GB, but that would be sufficient for all our analysis. I'm unable to log into NCMRWF network. Okay, fine. Then I'll just use my continue with today's class. Yesterday I finished with reading. I mentioned that today we'll be discussing about how to read CSV file or the text file containing the numbers, and how to load into our into NumPy array. Suppose if we have some text file with a tab separated or say a comma separated with the new lines, how we suppose I'll show this the text file. Okay, this is the all India rainfall from 1871 to 1999. This is the 12 columns for the 12 individual months, and it starts from 1821 and goes up to 1999. Suppose if you are reading this in a normal Python program, how one can write? This is how one can write the program. Yes, you can go through with the number of length of the range. Once you know, like here we are just reading the f object dot read lines. It will read everything into list, and that list will be stored into this data string. Then we are just closing the file object. Once we get to know how many lines, so we'll just the length of data string, we are loop throwing with the for loop. Then we are splitting it, the tab separated, because this is tab separated. You can see that. And then float. We are converting this string into float. Finally, we are storing it. So instead of that, we can do it in NumPy in a single command. So I'm just reading this. There is a function called load text in NumPy. This is a text file. So I'm going to use, I'm telling what is the delimiter, like either it's comma separated or tab separated. I'm just giving space. Then I want to utilize the calls, like a number of. This is a 0 column. This I'm going to skip it because this is string, which NumPy will not read. It will read string also, but the entire data should be string. As I mentioned yesterday, the entire array should be same data type. So I'm just skipping the first column, then number first row, 0th column I'm skipping. Then there is use calls 1, 2. There are 13 columns, and skip rows. So I'm just giving the first row like 0 rows because it is starting with some header. I use more argument, but I forgot. I'll show you that. If commented line is there, like, then that will be skipped. Let me try. I forget the syntax. And next, I'll just go with the help line. Commands with hash, then delete and it's wrong spelling. And you can see that skip rows, use calls, unpack true or false. Let me do that. Okay, it says that could not convert string to float. So I'm just using wrong number. There is string inside. wasting time. Okay, I'm just so let me use comments also. Deposits. Just index out of range. Okay. Okay, let me just get it as a comma separated. Oh. Yes, because I was given not proper delimiter, so it was having multiple space, so I just removed with the multiple space into single comma separated. Now let me load the entire row, entire columns. And I have taken some wrong example. Okay, use columns. Okay. I just read the third row 0 1 this one. Okay, when I read this value has been written, so let me read at least this one 1 2 3 4. Okay, that's how it became big numbers, because when I replaced with the comma, some mess up happened. So however, I'll just skip this demo as of now. You can use this load numpy.load text command. It will load your entire CSV file or whatever the text file into multi-dimensional array. Yeah, then finally, what is CDAT? It's designed for climate science data, as well as weather data also can be used. First released in 1997, based on OOPS Python computer language, and it is having red package that are useful to the community climate. climate community and other geophysical science. And this is the main thing. Today we'll see that what is CDMS, Climate Data Management System, and it is packed over the NumPy, also masked array. The main thing is it is returning the meta information. Also we have visualization, its own package called VCS, and we can add supporting library like IA graphics, XM Grace, Matplotlib, BTK, Wise. Also graphical user interface is there, and this is the one yet another powerful called CDML or XML. This is if you are using NCL, then you will come to know the NCML, and it is integrated with the LAS, Open and App, ESG, and the latest one like Jupyter also there, and this is based on BSD open source license. Okay, then let's go with the CDMS. So it can read and write. It can read CDMS, sorry, NetCDF file. NetCDF means a network climate data file. That's a NetCDF, and HDF file is a hierarchy directory file, and grib1, grib2, pp file, ff file, DRS can be read. So what is the syntax? Is just import CDMS2 version 2. So CDMS2. Then similar to our file, normal file, we're just using the cdms2.open and our NC file. Similarly, you can write your file name.nc with write mode, and you can write your data, or you can read the append mode or plus. Let me, yeah. Suppose if we have some NC file, some path, this is our data path. We just imported CDMS2, then we are opening that NC file. Then immediately what can be done? So once we open, first we want to know what are all the existing variables available within the NC file. So we are just doing f.list variables. It will list out the variables available. Then once you find some variables, immediately we want to see what is it contains or what is the meta information. So using square bracket, you can get the meta information without loading the entire data. Suppose your NC file may be having like a 2 GB or 3 GB file. You no need to load an entire 3 GB into RAM just to display the meta information. So in that case, we can just use this square bracket. It will just bring only the meta information. Or if you want to load everything into memory, then we have to use this square bracket. Sorry, normal parenthesis. Within that, we have multiple arguments that we will see it now. So once you loaded, you can get the .info, whatever they either partially loaded or fully loaded. You can use the .info and you can close it. Let me do it. So I have add AST. This is the actual add AST. I'm going to read it. This is a like alias which I made it with the previous versions installed in my another server. So what I'm doing, once I loaded, I'm just reading its list of variables. So it contains SST, and also it contains bounds, latitude, longitude, but also meta information to this SST. So once I just want to do the info, I can do it directly like this. So this is a variable. So it is giving all the meta information. ID is SST, and its shape is 1743 by 180 by 360. So we know that 180 by 360 is latitude longitude, whereas 1743 is the time index. So that much time dimension is there, and like file name is there, and grid size is it's showing this, and grid type would be like either it's a Gaussian or regular. Right now it doesn't have such a meta information. Long name you can keep it like sea surface temperature. Units is Celsius. Standard name is surface temperature. Cell method. So what they mentioned, like they made time axis mean, and time is the first axis. So it's a monthly data. You can see that month since 1870, and start from 0 and they lost at 1742. And similarly latitude, it's a degree north. Total length is 180, starting from 89.5 to minus north to south. And similarly longitude, so it's minus 180 to 180. You can do operation like dot shape, but if you are using the square bracket, I mean normal parenthesis, it will load entire data into our memory, which we don't want, because we will never utilize all the data at a time. Even if you are going to plot it only 1 month or 1 year annual mean, that's what we are going to plot it. If it is really needed, then you can load it. So next I'll show how to read. Suppose this is our like variable. Here we are just show the example.sst. So if you want to just in time slice, if you want to load it, there is an argument called time. Then within parentheses, we can keep the start time and end time. Or if you have some other dimension like latitude, longitude, or pressure, or level, that dimension name also we can specify start point and end point. Also we can keep the multiple point. So I'll just load the first one. I'm just using slice command. I just loaded the very first month. I put dot data. It will show the data. Yes, it's a fully like a masked. Since it's SST over land, it is masked. It is having information over only the ocean. Just with continuation of that, I forgot to mention in NumPy one more argument is there. Masked array. In NumPy there is one more method called masked array is there. First let me explain that, then I will come back to this. you can create a masked array. So it's just a masked array, not just no numpy array. It's just a masked array. There is no mask. Number size is there. Mask is false because there is no mask. If you want to mask something, if I'm just masking it less than 5, a less than 5, so it just return the mask with the wherever the condition is true. So if mask is true means that place it is, that location is masked. So you can create numpy.ma.mask. You can create numpy.ma.mask underscore less data less than the value. So less than this, whatever the value, it is being masked. The masked location we can see with the hyphen or dash dash, and it's a corresponding mask. Also, you can see the true value here. The first 4 being masked. It's just a mask. Mask means, oh, we know that why we are using mask. Suppose in land there is no data for the sea surface temperature, so it has to be masked. So in data science, 0 is a value. 0 is not just a, it's just not a unknown value. 0 is a value. In rainfall, 0 is the value. So if suppose in observed data, if you don't have record or observed record, we should keep it as a masking, not the 0, because 0 is a value. So masking is used in these kind of terms. Similarly, you can do mask the greater. Now a greater than 5 being masked. Now that you can assign into some b value also. So this b is containing masked array. A is just a original array where mask is false, there is no mask. But B contains mask. Wherever is true, wherever the true is there, those locations are being masked. So suppose if you want to fill this B wherever the mask is there, if you want to fill with some numbers, say -100. So wherever this masked, those locations being replaced with the -100. So this is the continuation of with the numpy and masked array. Now let me go with the SST. SST.shape. I'm just printing with SST. SST is right now you can see with the masking. If you just do mask, you will get the true or false, true and false. If you just want to get the max, you can see that. I hope you can see that. This first month SST is like 29 degrees Celsius. You can get the minimum and mean. Likewise, you can do all the data meta information. You can get it. Suppose if I'm just want to know what is this SST time, you can use this get time function is there. Just bringing the only 1 month, because this SST contain only 1 month data. It shows that only one time dimension is 1. But suppose if you're accessing the entire SST from the variable, then its time access is, you can see that length is 1743 months, whereas this SST which we store, that is having just only one month. Let me show you what is this month contains. I guess it's this is starting month 1870. Similarly, You can get it for here also. So these many start 1850. As I mentioned earlier, we can get the SST. Just load with SST1. You can get past the time also. The example we have seen. I'm just using this as a string. So this is just starting my index. I'll go with the entire year. You can understand this is January and this is December. Now it's loaded with the 12 months. It's just loaded with the 12 months from 1870 January to December. Suppose if you want to load with the 2015, that also we can do it. Let me load only 2 months. It just loaded with the 2 months, and you can see that its time is 2015 January and February. So basically you can split the time axis, and we have seen that a dimension name also, that I'll show it now. Yes, I'll show that. So what is our SST shape? This SST shape is 180 and 360. Let me open now over our Indian region. Like -10. -10 means there's a 10 south, and then let me go up to 20 north, where that Arabian Sea crosses. I'm just slicing to latitude. You can see that now latitude dimension has been reduced to 30. Let me use the longitude also. Is 60 to 100. Now you can see that its first dimension is time, which we reduced to two time points, 2015 January and February, then 30 latitude, 40 longitude. You can see that now just info. So just a minus 9.5 to 19.5. That's a minus 10 to 20 north. Since already our data is going with the 0.5 interval, so it has just brought that latitude. Similarly, longitude 60 to 100 I kept, so it's just brought 60.5 to 99.5. So you want to list out all the latitudes, you can do get latitude. Get latitude, you can use this list. It's just listing out all the latitudes. Similarly, you can do the longitude. Similarly, you can slice through the level also. If you have, if your data contains level or pressure level, you can use the level argument. And next, we are going to see about the CD time. It contains this module available in the CDAT. This is very useful in terms of time object management. Import CD time. Then you can convert or create relative time, like CD time dot relate time, like 19. Then you can put in an argument day since some date, so that will create that many days. Let me show that. CD time, then relative time, CD time dot from today. Let me go with next 20 days. Days since 2020 April 7. So just produced 20 days since 2024 7. So just bringing, you may be thinking that it's just printing it, but it's a object. You can see that the CD time related time object. Whoa. If you want to know what all things can be done using this, you can do add to another time. You can compare. You can subtract. So there is a function called toComponent. So I'm just going to use that. You can convert this into printable component. Now it just it has gone ahead of 20 days. And just store this. C is a component. It's just not a string. You can further see that what is containing this component time. It's also having so many methods. You can convert back to relative or fraction. Let me do it. C dot year. Just a break. Since C is an object, it contains the year method. Year is another. C dot month, C dot day. So you can get C dot hour. Hour you can go up to minute and seconds. This C also you can again convert back or convert to relatives. This component, do you want to, you can go to related to something else. Say again 20 days. Sorry, this is. It just converted back to again relative time. You can go with negative also, negative number also, it will go back to the previous days. So these are all facilities available in CD time. You can further you can do that. So if I'm just doing VAR CD time, so it is having months, hours, and no leap calendar, seasons. So it is having some predefined seasons that I'll show you, like all the seasons available, JJA or MAM, JJA. The standard 4 seasons are available, and also annual is there predefined. We will see one by one. And moreover, this let me explain about arrays and masked arrays. and masked variables. This we understand this since yesterday we are talking about NumPy 2-dimensional. Yesterday we have also seen the 3-dimensional. So this is just for example 2-dimensional array. And today I showed the demo for the numpy.ma. It's just having array plus mask. Once we mask, it just return the masked array. And in CDAT, one more data type called MV2. It's a masked variable version 2. What it contains array and mask information plus domain in terms of latitude or longitude information, plus further meta information like ID and its units that is called a masked variable. So that's what we have seen so far. Like this. So this entire numpy or numpy.ma variable has been read through as a MV2 variable with all the meta information, ID, units, comments, then it's the dimension meta information, time and latitude, longitude. Yeah, just so here what the example is, just if we have some numpy array, you can do all the operations just a simple numpy array, whereas this is numpy.ma masked greater sum a equal to 4. So this also explained. So it is containing these masked, these elements are masked, and it's a masking true or false has been shown. And MV2, this is having all the meta information. This is what our interest. We should do all the operation of numpy also retaining our meta information as long as possible. Like whatever operation we are doing, grade or whatever stuff, it should retain its meta information so that we can write into any time to the NetCDF file. So summary, we can say that take advantage of NumPy arrays syntax to make operation with arrays both faster and make more flexible. So there are multiple Python packages other than CDAT, PyNIO and PySclinch, PyTables, Scientific Python to handle CDF, HDF, etc. But in CDAT, I'm more comfortable. For past 10 years, I'm using it without need of any other package in Python in terms of accessing our climate or weather data set to produce publishable figures also. So I acknowledge Dr. Johnny Lin, who made this presentation, and also I'll go with we'll just go through this 2 more slides. Yes, this I already showed you how to. Yeah, one more thing I'll just mention to this. Yeah, you can select through the time, latitude, longitude. Let me go back to. Yes, this SST dot shape contain 2. Suppose if we have single dimensional, let's say I'm just importing only one dimension, one time dimension, this one. If you don't want to list out this first dimension or single dimension, you can use a squeeze option. Squeeze, I'm just enabling it to 1. Now it will become just it just remove the single dimension. Also, you can change the order while loading. You can choose the order which you want. First I'm doing time, then y dimension is latitude, and x dimension is longitude. So just bringing this same shape But if I go with the difference, say first I'm bringing latitude, then time, see that it just reorder the using the reshape command, but we are giving the options through our lat long index. So you can rotate you can rotate your cube once you load it, or while loading itself you can rotate your variable whatever order you want. Preferable order to preferable order is time, then latitude, then longitude. That's a T, Y, X by default. That's the order. If we have level, then level should be second argument, like time level, then latitude, then longitude. So this is what we have seen so far, and I'll discuss about this bounds in the latitude tomorrow onwards. Also, we can do multiple CD utilities there. There we can do the averager, vertical average, and region wise we can select predefined region is there, or we can create our own region. Similarly, you can do time operational in terms of selecting the seasons or take the average over the seasons. Also, we can do regridding. Also, the statistical operations are there, like you can do the correlation, standard deviation, and you can calculate EOF, empirical orthogonal function. So many things are there. I'm not showing all the stuff. I'm just giving the glance. Once you are getting interest into the CDAT, then yourself can learn multiple things. So already 4:52. Let me go to question session. Please ask your questions here. Yes, and somebody asked the question. So header info can't read in NumPy. NumPy is just numbers. It doesn't have any meta information. That's why in CDAT they build the meta information where it's always repeated or. Also, I mentioned the homework session. Yesterday is give some homework to your email, and those who are watching in YouTube, in comment section also I mentioned the homework. You can go through it. Let me explain the question once again. So write a Python script to display nth multiplication table up to mth times. So get both n and m numbers from the user. For example, if n is 2 given by the user and m also given by user as a 3, then it should display as follows, like 1 cross 2 is equal to 2, 2 cross 2 is equal to 4. So likewise up to m times. And once you displayed it, you should write that output into some text file, say n and m. N and m should be replaced with a 2 by 3 in this example. So this is just a Python for yourself to learn how to read or how to write into some text file. And problem 2 is add more mathematical operations like subtraction, addition, division to the problem 1. That also you have to get it from the user, what operand they want to display as a tables. And homework problem 3, you have to generate a 3 by 6 random integer numbers varying from 10 to 40 using numpy.random function is there, and find yourself how to generate. The value should be within 10 to 40, the random numbers. Then mask it wherever number is greater than 20 and numbers less than 30 without using loops, and your script should not exceed 3 lines including import statement. So that's the challenge. Just 3 lines. And similarly, 4, problem 4, fill with the e to the power or 10 to the power 20 wherever masked in this result. That also in 3 lines. Okay, I will share this PDF file and I will keep it here, the same location, and share it here. To also comment in the YouTube description. Let me go to the chat box. I'm able to get chat. Yeah, I couldn't use the link to ask question. Please, I want to ask how can I read a different NC files, especially data from trim. You can read what are the NC files, either NetCDF3 or NetCDF4 or NetCDF4 Classic. All the NC files you can read through in CDAT, just as I showed in the example. So it's already about 5. So if you have any doubt, please ask it here or mail me or write down in the question session. Yes, this question I understand. Suppose if we have multiple NC files, I think I'm understanding correctly. If we have multiple NC files, tomorrow I'll show a demo how to read all together without merging those NC files. Suppose if we have thousands of NC files, we have utility called CD scan. Once you scan it, it will produce one XML file. Using that XML file, you can read all the thousands of NC files without merging it. So tomorrow I'll show the example for that. Tomorrow I'll show demo for whatever I mentioned, like CD util and gen util to do average, area average or time average. We can do it. Also, like subsetting the season wise or subsetting take the area average or time average. That also I'll show demo. Then regridding also I'll show demo. So with that, tomorrow we can finish it. Then day after tomorrow I'll show the plotting stuff using CDAT. Then on next day I'll show the CDO. Using CDO it can be utilized in Python and Iris. With that I will conclude the session. And one more thing I just want to mention in CDAT. So if you come to GitHub page in CDAT, you can see that it is community development. You can see that more than 30 contributors are there as of now. These are all the contributors or the coders who come contributing or developing these CDATs.